Hello and welcome to another one of D's ADD videos. Today we're going to be discussing the final rule of the advanced trig integration dealing with tangents and secants. Again, when we're dealing with tangents and secants and integrals, and it's not a simple u sub, depending on which scenario we use, the exponents must be greater than 1, positive. If you've watched the other videos, you already know there's one of 3 scenarios we're going to deal with. We've already dealt with number 1 and number 2, so now we're going to look at number 3, when tangent is even. Now, when tangent's even, it's a slightly different scenario in which what you're pulling out is not going to be your du in this scenario. Up until now, what you set aside was your du, but not this one. Again, each of these have their own method, what you take out, and what's going to be your u. And in this case, if tangent is even, what you're going to do is you're going to pull out a tangent squared and then use your trig identities to convert it into secant squareds. The actual tangent squared you're converting, not what's left as in before. So let's look at this example here. This example here, we are going to have a even tangent. So what we do is we've got to, like this says over here, pull out a tangent squared. If we pull out a tangent squared, this is what would happen. And normally in this scenario, we would say this is your du term, but that's not your du term here. We're going to convert this into a secant squared minus 1 and continue to do so until we no longer have even tangents that we have to deal with, or sometimes we can just get away with doing a u substitution and be done with it. So now what we're going to do is we're going to use a trig identity. Like before, tan squared equals secant squared minus 1. You can do sine squared plus cosine squared equals 1 if you forgot how to get to here, and then divide everybody by cosine squared. So when you plug in, this is what you're going to get. Now at this point, you can distribute through and create 2 separate integrals. The first one, hopefully you can see that as a u substitution. Hopefully you can see that where u equals tangent and du is secant squared. But guess what we're going to have to do again here? Tangent is even. So we're going to have to pull out a tan squared, do it one more time. Okay? We got to keep going until there are no more tangents that are even left. Alright, so this is kind of different than the other ones, because before this was my du and we would convert this into secant squares. But now we're actually converting what we pull aside into secant squareds using your trig identities. Alright, make sure you know your trig identities. As always, practice, practice, practice. Check out the example videos. For best results, pause the example videos, then try the problem, and then watch the solution. I hope this has eliminated enough of your doubts to attempt some problems, because that's the key to understanding all of this. Thank you for watching, and have a nice day.